All right, so today is a day one lesson of 2 again. So our essential question is, how do I find the probability of independent and dependent events?
So events are independent if the occurrence of one event does not affect the probability of the other.
Got it.
That makes sense. So here's a little example that we can talk through.
Okay.
If a coin, quarter, nickel, dime, penny, is
Whatever.
tossed twice, it's landing heads up on the first toss and landing heads up on the second toss are independent.
Because every time they have an option to get heads or tails.
Exactly.
Got it.
The outcome of one toss does not affect the probability of heads on the other toss.
Okay.
So to find the probability of tossing heads twice, you look at the probability of tossing it once, which is 1/2, picking up the coin again, and what's the probability of tossing heads again? 1/2. And you have to multiply the two probabilities together, which would give us 1/4.
Okay.
And there's the formula.
Yep.
The probability of independent events, if they're independent, you multiply the probabilities together.
All right.
So here is, trying to get to the next page here. Let's try it going this way. There we go. Example number 1. A 6-sided cube is labeled with the numbers 1, 2, 2, 3, 3, 3. So it's not a regular cube.
No, it's a different one. Okay.
4 sides are colored red. 1 side is white, and 1 side is yellow.
Okay.
So we're going to find some probabilities here. Find the probability, and the minute we say probability, it's a fraction. So find the probability of tossing a 2, then a 2. So we're going to do one probability at a time.
Okay.
So how many sides are on the cube?
6.
That's our denominator. And how many 2s?
1, 2.
That's our numerator. Right. Now we times it by the probability of tossing a 2 again, which is going to be same, 2 over 6. When you multiply fractions, you multiply straight across.
Yes,
2 times 2, 6 times 6 is 36, and you never leave your answer like that. You always reduce it to simplest form.
All right.
Done. Let's go down here. We might have to float back up, I guess, to see our numbers,
Yep.
but tossing a red, then a white, then a yellow. So let's go back up so we can see.
So right away, I know I'm going to have 3 fractions. So there are 3 different events.
Right.
And we know they all have 6 sides.
Right.
So I'm just going to put the 6s right away.
Good.
Okay.
How many sides are red?
It says 4.
Right.
So 4.
Yep. How many sides are white?
Is 1. And yellow is 1.
Yep. And now we multiply straight across.
4 times 1 is 4 times 1 is 4.
And then 6 times 6 times 6 is 216.
Oops.
Not 16.
216. Got it.
There we go.
And that for sure reduces.
Yep, and that actually reduces to 1 over 54.
Nice.
And there we go. Nice. Okay.
All right.
Let's go down to example 2. We're kind of on a roll here. Find each probability.
All right.
What is the probability of rolling a 6 on one number cube and a 6 on another? Now, we have to be careful here.
Normal, or
now, see example 1.
That didn't have any sixes.
Right. So here we go. We're on now a different problem, and if it doesn't tell you a special cube, you assume it's a regular cube.
Or fair number cube.
Okay, got it.
Okay.
So what's the probability of rolling a 6 on one number cube and a 6 on another number cube?
Well, there's 6 options, and then there's 1 6 on a dice.
So I take it, and I'm rolling a single cube. Boom. Now I take it again, and I roll it again.
Still 6 options.
Yep.
Still 1 6 on it.
And if we multiply that,
36.
be very careful though, Miss Boyd.
Oh, I
because
added.
1 times 1 is 1.
1. Oh boy, I do that all the time.
And we're
we're done because you can't reduce more than 1.
No.
Sweet.
Okay, so let's go down to the next one.
All right.
Tossing heads. So now we're talking about a coin.
So there's
Tossing
2
heads.
options, heads or tails.
And tossing heads again. And then tails.
So heads, then heads.
Then tails.
Then tails.
And tossing a coin 3 times.
So there are 3 options.
Right, so the probability
heads, well, 1 out of 2. Heads, 1 out of 2.
Right.
And tails, 1 out of 2.
And if we multiply
1
that,
times 1 times 1 is 1.
2 times 2
times 2
times 2
2
is
is
8. And we're done.
Great. Oh, these are easy enough. Good.
I know, they're very easy actually.
I like them.
Let's go to the next page.
Okay.
Okay, we've
Now we
talked
have
about independent.
Yep.
Let's talk about dependent. That means the occurrence of one event affects the probability of the other.
So it depends on the other one.
Right. Here's an example, and we also are going to do an example in class. I use a lot of props in this chapter because it helps a lot. So for example, suppose that there are 2 lemons and a lime in a bag. Okay, so 2 lemons and 1 lime in one bag.
Got it.
If I pull out 2
I'm gonna just draw like
pieces, So if you pull out 2 pieces of fruit, the probabilities change depending on which piece you pulled out first.
Right.
So let's say, for example, let's see, what did we say? 2 lemons and a lime. So the probability of pulling, oh, I like that. The probability of pulling out a lemon is going to be 2 over 3. Thus
Yes,
the 2 over 3.
2 out of 3.
The probability of pulling out a lime instead of any lemons is 1 out of 3.
Out of 3.
So now let's go the lemon route right
Okay.
now. If we pull out a lemon.
So this is our first
Yep.
pull. So whatever.
So if we pull out a lemon,
Mhm.
that's a 2 out of 3 probability.
Right.
Then
Are we keeping it out or are we
we're
putting it back
keeping
in?
it out.
Okay.
Then the probability of pulling another lemon just going to be 1 over 2
Right.
because
if we pull one out,
there's only
gone,
one left. And there's
now
only
we only have one out of 2
total.
options. Got it.
And the probability, again, going down the lemon route, if we pull a lemon out first,
Mhm.
and then the probability of getting a lime
Would
is
still
going to
be
be
1
1 out of 2.
Got
All
it.
right? So that's that route.
Okay.
Now let's go the route of pulling out a lime.
Okay.
The probability of getting a lime is 1 out of 3 because there's 1 lime.
Right.
Once I pull that lime out, the probability of getting another lime is 0.
Gone.
That's why it says 0 there.
Yeah.
The probability of getting a lemon, though, is going to be 2 out of 2, which is
reduces to
1.
1.
All right?
Okay,
That makes sense? We'll do an example in class on that. So to find the probability of dependent events, you can use conditional probability, meaning the probability of B given A. The probability of event B, this is what this means, the probability of event B given that A has already occurred.
Okay.
That is what we just did up there.
Got it.
And there's the there's the formula for the probability.
And we'll
We're
do
going to
an
go over an
example.
example.
Yeah.
So let's go to the next page. Here we go. Example number 3. And actually what I'm going to do is I'm skipping 3. And
Okay.
there's a reason.
Great.
And I think there's a reason. I'm going to make sure. I'm going to go to example 4 for a minute. Yes, I want this chart.
Okay.
Okay? And I know it's hidden behind here, but it is in your notes. We'll
Mhm.
do example 3 in class.
Okay.
This is a chart that you need to memorize and know how to make because it's going to help you on these problems. And it's
Right.
so easy.
Right.
Because notice all you're doing with this chart is
Matching up numbers.
right. 1, 2, 3, 4, 5, 6 in blue all the way down, and then it's 1, 1, 1, 1,
1,
2, 2, 2, 2, 2, 3, 3, 3,
Got it.
and so forth.
Easy enough.
So here's the problem. 2 number cubes are rolled.
Okay.
Here's the trick. If the problem ever says 2 number cubes are rolled, that is the table you need to make. There's the key word.
Make table.
1 white and 1 yellow. Well, yellow, blue, whatever.
Yeah.
Explain why the events are dependent and then find the indicated probability. All right?
Okay.
So this is the probability we're trying to find. The probability that the yellow cube, the ones I highlighted, shows an even number and the sum is 5. Now on your notes, I don't have it in front of me. I don't know if the yellow highlight is going to show up or not.
So you might want to highlight
So you
it.
might want to highlight, you can tell by our screen what's yellow and
Mhm.
what's not highlighted, we're calling white.
Okay.
Okay, so the reason that it's dependent is this, because the first probability, the probability that a yellow cube shows an even number is first.
Okay.
Then the sum, that probability depends on the first probability
Okay.
showing an even number. So what I like to do on this type of problem, Ms. Boyd, is I like to do it in pieces.
Yeah, me too.
Okay, so I'm going to go like this. The yellow cube shows an even number. Let's circle
Yep.
the pairs where the yellow is even.
So none of those.
None of those.
So all of these.
Yep. Mm-hmm.
Great.
Good.
None of these, but
And
all
those.
of these.
Notice what Miss Boyd's circling. Everything where the yellow cube is even. And
Got it.
we're circling always pairs because when you roll
None of
2
these.
cubes, they always are common pairs.
Right.
Because you roll 2.
Okay.
So now,
We got to count those up.
right,
Right.
how many are there?
1, 2, 3, 4, 5, 6. There's 3 rows of 6, so
That's
18.
18. And how many total?
36.
Yes. That's our first probability. That's
Okay.
the probability A that we talked about in the formula. Times, now guess what our denominator is going to be?
Well, we already used these.
That's our denominator.
So now our denominator is 18.
And that's always going to be the case on conditional probability.
Ignore the pairs we've already found, right?
Nope, we don't want to
Oh,
cross
'cause
that
we're
off because we still got to go to that.
Got it. Okay,
So
it's fine. I can see it.
we'll just do different colors,
Yep,
okay?
different
But
colors.
the 18 is correct.
Got it.
So now out of those
Out
18,
of those 18,
which ones have
gotcha.
a sum of 5?
Okay,
So
so
that's
right here we have
3 plus 2,
none.
4 plus 1,
none of those.
and that's
And
it.
that's it.
So
And then
how many?
2 out of 18.
Exactly. And
Got
look
it.
what happens. The
Multiply 'em.
18s can cancel.
Oh, yeah, easy enough.
And then all you end up with is 2 over 36, which is 1 over 18. That's
Great.
always going to be the case.
Okay, so you find your first thing first, and then out of that first sample space, one
Right.
might say, then find the second thing.
Exactly.
Okay,
Does
makes
that
sense.
make sense? Okay.
Because of the and, so you had to do
That's the
both.
and. They're
Got it.
dependent on each other. All right.
Got it.
Let's go to the next page. And I think that's it actually. And it is.
Great.
So I'm going to float down so they can
Yep,
see those
perfect.
answers. So 2 number cubes are rolled. This is just like the one we did.
Okay.
1 red and 1 black. What is the probability? Ooh, I spelled that word wrong. Sorry about that.
That's okay.
That the red cube shows a number greater than 4 and the sum is greater than 9. So Miss Boyd,
Mhm.
should we circle for them right now? The red cube shows a number greater than 4.
Red
would that-
cube shows a number.
The
greater than four.
pairs,
So
yeah,
this one right
greater
here.
greater than
So
4.
not equal. Got
No,
it.
Yep,
All right, so let's
So it's gonna
do
be the
this.
5,
So
1.
5 and 1,
6 and 1,
6 and 1.
5 and 2,
There we go.
6 and 2. See, where the red cube is greater than 4.
Got it.
5 and 3, 6 and 3, 5 and 4, 6 and 4.
Sorry, they're not going to be able to read.
That's
which
okay.
ones.
They'll,
Well, you
5 they
figure
can
it out.
count. 5 and 5, 6 and 5, and 5 and 6, 6 and 6.
Got it.
We got you started. So that would be 2, 4, 6, 8, 10, 12 out of 36 would be your first probability then. And then, given that, now we'll let them finish
Okay,
this.
go.
How many have a sum
Some
greater than 9?
Some adding.
So I'm going to float down those so they can see.
Good.
There's your different options for your multiple choice.
Okay.
And then the next one is 2 number cubes are rolled, 1 red and 1 black. What is the probability? The red cube shows a number greater than 3. They can do this one on their
Oh,
own.
yeah.
And the sum is less than 8.
Okay.
Pretty darn easy.
Yeah.
And there's your options again.
Okay.
We're
See you
done.
tomorrow.